Good morning, everybody. My name is Alycia Triplett. I am a graduating senior at the I Love Jackson State University. And this summer, I had the opportunity to work with the La Crosse, Wisconsin Weather Forecasting Office, investigating thunderstorm speed and its relation to fatalities. Okay. So on the evening of July 19th, 2018, a very fast-moving band of storms, often referred to as a derecho, passed through the Table Rock Lake area, which is located in southern Missouri. There's a really popular tourist attraction there, duck boats. And on this evening, the duck boats had went out for their last rides of the day, and this derecho moved through, and there were 17 people lost their lives because of this incident. 7 others were injured. There were 31 people aboard the duck boat in total. The Springfield Airport reported a wind gust of about 60 miles per hour about 30 minutes before this incident happened. So the image on the screen shows the radar image from this day. If you see the gray area where the red dot is Table Rock Lake, the gray band you see is a outflow boundary, which is basically wind that was ahead of the storm, as you can see from the image. So why was Table Rock Lake significant? Well, like I said, 17 people lost their lives. So the National Weather Service Central Region had to investigate this to see what could be done from the National Weather Service's perspective to better the messaging and the specificity of the messaging to make sure that things like this don't happen again. So the Storm Prediction Center and the Springfield Forecast Office were updating messaging throughout the day. And I would also like to note that at the time when this was in July 2021, when this was relevant, the owner of the duck boat company, the manager on duty the day of the incident, and the general manager were all facing felony charges. But as of yesterday, those charges were dismissed. So, but we're focusing on the National Weather Service side. So from the outcome of Table Rock Lake, we had to ask ourselves, do faster storms result in more fatalities? Does warning messaging have an impact on injuries and fatalities? And what else can be done to emphasize the importance of preparedness to partners and the public? So to collect this data, I downloaded archive storm data into GR2 Analyst, which is a radar software that the National Weather Service uses. Our initial goal was to collect hail events, thunderstorm wind events, and tornadic events that resulted in at least 1 injury and 1 fatality. But unfortunately, I only had 9 weeks to work on this project, and that's not a lot of time to do all of that. So we decided to focus on thunderstorm wind events that resulted in at least 1 fatality. So from GR2 Analyst, I gathered the observed speed and direction of the system of storms, or if it was a cell, the storm cell itself. If there was a warning, I recorded the forecast speed and direction of the storm from the warning. I also noted if there was an outflow boundary present. And then from the warning information, the date, the time, and then impact-based warning tags, which I will touch on later, the fatality location, and where the location was listed in the warning, if it was listed at all. And so the location could have been listed in a location's impact at the bottom of the warning, or it could have been in a pathcast, which provides a specific time the storm will reach a specific area. So I was able to collect 104 fatal thunderstorm wind events from 2017 to 2020. The average observed radar speed was 39 knots. You can see from the figure on the left that most event speeds were between 21 and 31 knots, but 54 knots occurred the most. The figure on the right shows the correlation between the observed speed that I collected from GR2 analysts and the forecasted speed from the warning. And you can see that both those speeds had, the forecast speed or the observed speed had just about a chance of being correct as it did being incorrect. It's ideally the line would be a one-on-one relationship, but you see there's kind of like an even scatter on the graph. So the average lead time for the events was 32 minutes, but for most events, as you can see, it was between 0 to 15 minutes. 74% of the events were warned, and 71% of the events had a radar detectable alpha boundary. That really surprised me, actually. So these figures are courtesy of my lacrosse mentor, Clint. And so if you imagine taking the contiguous United States and dividing it into like 9 pieces, there's a WFO in each of those 9 regions. It is worth noting that there were no fatal wind events collected for the Seattle, Salt Lake City, or Miami forecast offices. And only one event was collected. The one event collected for Phoenix was not warned. So there was really no information to use for that area. So if you look closely, you can see a black line on each of the images, and that line represents the average warning forecast speed of about 40 knots, which is about 46 miles per hour. For 4 out of the 5 events, 4 out of the 5 locations on this figure, all of the fatal events had a higher wind speed than that black line. And then 2 of them had a higher wind speed than the calculated forecast average. So earlier I mentioned impact-based warning tags, and I said that the locations could have been listed in a locations impacted listing or a pathcast in a warning. So out of the 77 warned events, 29 of them did not include the location, the death location in the locations impacted listing, and only 13 of them utilized the pathcast. Which is surprising because pathcast is more specific than locations impacted, and you would think that that would be more moving to the public, emergency managers and forecasters, but only 13 of them were used. So we thought it would be interesting to look into the new impact-based warning tags that the National Weather Service rolled out in the summer of 2021, which ironically I worked on in the summer of 2020. So as you can see, we were looking to see where these events would be placed in these new categories under these new impact-based warning tags for severe thunderstorm warnings. So 50 knots or 58 miles per hour is minimum wind speed for a thunderstorm to be considered like a severe thunderstorm. And so the considerable tag starts at 70 miles per hour, and the destructive tag starts at 80. So now that we have all of this, the graph on the left shows where the events would have fallen in their initial warnings. The graph on the right shows the maximum tag an event would have received. So 15 of the warned events were either upgraded to a considerable or destructive under these new tags. So now that we have all of this wonderful information, it's important to find a way to use it. This was also courtesy of my WFO mentor. And so the idea behind this project was to figure out what can be done regarding these faster moving storms. So this is a image of the La Crosse County warning area. And so the idea is that if there was an outdoor event such as a concert or a sporting event, then we would need to determine the speed of the storm to determine how quickly we need to evacuate that outdoor event. So if 30 minutes was needed to get everyone out safely, then a larger area would need to be evacuated as storm speed increases. And we sent this out to emergency managers in the county warning area, and they thought that this was very useful. And they're looking forward to seeing it sometime in the future. So to sum everything up, faster storms do and did increase the chances of fatalities. Although we learned a lot from these cases, more data is always nice. I feel that we should limit it to a specific forecast office or a county warning area instead of using it on a national basis, because that's more useful for local communities. Warning messaging should also be looked into. While I think the National Weather Service does a great job of communicating threats, as they did at the Table Rock Lake incident, it's probably be helpful to increase the use of halfcasts as it's more specific and straightforward. And the public is more likely to act if they see their city's name or their town's name at a specific time on warnings. Sources, acknowledgements. Are there any questions?
Thank you very much, Alycia. Any questions? We have time for one or two. Yes.
I have a question. So I'm not all familiar with with all of these storms and how they're related to each other, but does storm speed, is there a relationship between the storm speed and then the intensity of the storm? Because I was kind of thinking maybe there's kind of compounding effects, like, you know, it's the storm speed as well as the fact that it's a more intense storm is maybe the reason why these fatalities are also so large.
Typically, yes. And that's why we wanted to look into like hail and wind and tornadic events, because every thunderstorm does not produce a tornado, every thunderstorm does not produce hail. But those would be more intense storms. But like I said, we didn't get a chance to look at that, but that would be a good connection to look into in the future.
Okay, any other questions? Okay, yes.
Quick question about the last product that you showed. What is that a product that's kind of gone through kind of the social science kind of rigor with respect to understanding the needs of the user and developing the product in a visually appealing way that, you know, the user understands?
Yes, so that was the idea. It was like if we created this and we sent this out as a IDSS product, an impact-based decision support product, then it would be more useful to emergency managers and possibly the public, because there were really no words at all. It's very straightforward, and it's a good visualization of the effects of severe thunderstorms on outdoor sporting events and how that could be used in the future.
Okay, very good.